Hi, everyone. So now that we discussed another theorem which clarifies what is the previous theorem. Okay, so the theorem, the limit m goes to infinity, the I superscript m is equal to log of I, 1 plus I. So that is actually the delta we defined in the previous theorem. So remember that the I superscript m is the nominal rate, which is equivalent to the effective rate of I. And actually the interest compounds m times a year. So the force of interest is continuous compounding rate. So that means if m goes to infinity, that means that we compound the infinitely many times a year, then that should be equal to force of interest. So this clarifies what the force of interest is. Okay, so we would like to prove it. But before that, maybe we can just, and actually we can state this theorem as the delta is equal to just the I of infinity, I superscript infinity. Okay. And maybe another remark is that the delta is always smaller than I. Okay, so proof. The proof actually depends on the uses the definition of the derivative. Okay, so the limit. Okay, so we just start with the left-hand side. Limit m goes to infinity of I superscript m. So this is equal to m times 1 plus I 1 over m to the power 1 over m minus 1. So this has been discussed when we defined I superscript m. So you can see the previous video. And this is equal to, just by some algebra, the m goes to infinity, the 1 plus I, 1 over m minus 1 over 1 over m. So just the m becomes 1 over m, right? And here we use the definition of derivative. Okay, so maybe I would say that this is the definition of I superscript m. And this is the definition of derivative. Then this becomes the limit, this is the derivative of 1 plus I to the power x at x is equal to 0. Yeah, so remember that the definition of this is actually, to be exact, the 1 plus I to the power x minus 1 plus I to the power 0 over the 1 plus I, 1 plus I, so that is x, right? X, and the limit x goes to 0. But just when m goes to infinity, 1 over m goes to 0. So this is exactly the definition of the derivative of 1 plus I to the power x at 0. And this is the derivative of exponential function. So this becomes log of 1 plus I times 1 plus I to the power x at x is equal to 0. But x is equal to 0, then this becomes just 1. 1 plus I to the power 0 is 1. So this becomes log of 1 plus I. So this is the proof of the theorem. So now the meaning of the force of interest becomes clear. So the meaning, if the interest rate is the compounded in arbitrarily small interval, our nominal rate of delta, that is log of 1 plus I, makes the effective rate of I.